Okay, this is Unit 11, Solving with Different Methods. We have gone through each of the 5 methods listed below for solving quadratic functions. So, the important things to remember is I can use any of these to solve for x when y is equal to 0. So if I'm talking about graphing, I can be given the function f of x equals x minus 3 squared minus 16 equals 0. Or I can be given a function like y equals x squared minus 6x minus 7. And sorry, we would plug in the 0 for y, so that should actually be over here. But I want to know what my x value is when my y is equal to 0. So all I do is plug in 0 and then start solving. You could do this either way. You can do it by doing a table of values. And I know that the vertex, in this case, for this first equation, is 3, negative 16. So you can just start plugging in values on either side of 3, like 2 and 4, and continue in either direction to plot the entire graph until this function crosses the y-axis, or the x-axis. So when that function crosses the x-axis, we'll be given 2 points. And whatever those 2 points are solutions to the function. So in this case, it would be x equals negative 1 and x equals positive 7. I just wanted to show whether you are given a vertex form or a standard form problem, you can plug in the points for x and solve for y. And you would want to be looking for whenever your table equals 0, or when your graph is equal to 0 for y, which means it's sitting on the x-axis. These are actually the same function, and you could change one to the other by completing the square. And we're going to get to that in a second. Another option for solving would be to use square roots. A good example of this is if you had x squared minus 49 equals 0. I can tell that this is a good problem to use square roots on because I don't have a b term. A b term would be if I had a term that just had a singular x. I have an x squared term, which means I have an a term. I have a term without an x, which means I have a c term, but I have no b term. So that helps me to solve by square roots. I could add the 49 to the other side, which would give me x squared equals 49. And once you isolate the squared term, you use square roots to solve, which means I want to take the plus or minus square root of each side. The square root of 49 is 7, so that means my answer would be x equals plus or minus 7. I'm going to write that as positive 7 and negative 7. Okay, so just like above, I got 2 different answers. It was a different problem, so they will give me 2 different x values. I could get 2 real solutions, 1 real solution, or I could also get imaginary solutions. For factoring, the problems that, here's an example for factoring. Let's see. 5x squared minus 15x equals 0. I know that this problem is a good one to factor because my greatest common factor is in both of these terms, which would be 5x. If I factor out a 5x from each of these terms, I'm left with x minus 3. if you're multiplying two terms together, 5x and x minus 3, if you multiply those two things together to get 0, that means we set each of them equal to 0 to determine our solutions for x. Well, what number times 5 will give me 0? 0 times 5 will give me 0, so x equals 0 is one of my solutions. What number minus 3 will give me 0? 3 minus 3 is 0, so my second solution is 3. That would be a great one to use factoring on. We can also factor certain trinomials. This trinomial at the top is factorable, so it would be a good way to find these two solutions as well. But sometimes we come across solutions that are equations that are not factorable. So here's an example of something that is not factorable. X squared minus 4x plus 1 equals 0. I know that I can't factor this because I don't have anything that would multiply to 1x squared and add to negative 4x. So my solutions might be imaginary, or they might be irrational or something, but I can use completing this square to figure out more information. So I'm going to group up my x terms, both x squared and my x term, and in doing so, we are going to make a perfect square trinomial inside those parentheses, but I need to know what my c term is to make that trinomial a perfect square. This plus 1 does not help us with the perfect square, but since I added something to this equation, I also need to subtract the same number so that I balance everything out to 0. So that would just be like adding a 0. In order to figure out what number goes in that blank, we're going to do negative 4 divided by 2. That gives me negative 2. We square that. That gives me 4. So 4 is the number that's going in each of my blanks. I can now factor the trinomial to a perfect square. What number plus itself gives me negative 4? And that same number times itself gives me positive 4. Negative 2 plus negative 2 is negative 4. Negative 2 times negative 2 is positive 4. So that's why I get x minus 2 squared here. And then I want to do 1 minus 4. 1 minus 4 is negative 3. And now I can start solving by square roots. So completing the square, we'll have some mix of factoring and square roots and different things, but the important part is that we're making this be a perfect square trinomial. So I would add 3 to the other side when I'm trying to solve this, so plus 3 plus 3. And I get x minus 2 squared equals 3. In order to solve that, I want to take the square root of each side. I get x minus 2 equals plus or minus the square root of 3. Remember the plus or minus when you take the square root. And then lastly, to solve for x, I want to add that 2 to the other side. So I get 2 plus or minus the square root of 3. Now notice all these answers above had 2 separate answers. This one also has 2 answers, but we just kind of write them together. This is 2 plus square root of 3 and 2 minus square root of 3. If you would like to write those separately, then you are more than welcome to do so. The last way we solved in this class was by using the quadratic formula. It does not matter what my equation looks like, I can use the quadratic formula. So I'm just going to give an example. Let's say my question is x squared minus 4x minus 5 equals 0. Well, then I know my a term is 1 because it's in front of my x squared. My b term is negative 4 and my c term is negative 5. So what I'm going to do is plug those into the quadratic formula, which means I'm doing negative b, which is negative 4, plus or minus the square root of b, which is negative 4, squared, minus 4 times a, which is 1, times c, which is negative 5, all over 2 times a, which is 1. So that looks like a mess, but I'm going to be able to simplify that as we go, and it's going to simplify to positive 4 plus or minus the square root of, well, let's see, we're going to simplify this whole thing. So negative 4 squared is 16, and 4 times 1, sorry, negative 4 times 1 is negative 5. Negative 4 times negative, oh, I can't even talk. Excuse me. Negative 4 times 1 is negative 4, and negative 4 times negative 5 is positive 20 all over 2. Well, this simplifies in order to be a perfect square. So 16 plus 20 is 36, and the square root of 36 is, hopefully you said 6. So I get 4 plus or minus 6 all over 2. That just means this breaks up to 2 answers, and I'm going to kind of rope this off so that you can see what's happening. This will be 4 plus 6, which is 10, divided by 2, or 4 minus 6. 4 minus 6 is negative 2, divided by 2. You want to make sure you simplify your answers until you get a whole number if you're able to. So what is 10 divided by 2? Well, that's 5. And negative 2 divided by 2 is negative 1. So my two x-intercepts for this problem right here were x equals 5 and x equals negative 1. Okay, so your job is to right now solve the 4 problems below in the way you feel most comfortable. You might feel most comfortable by plugging things into a table and graphing it and see where it crosses the x-axis. But remember, if you're in between 2 whole numbers or 2 integers, then you will need to find a way to get a more precise answer. Remember, the quadratic formula works every time, but it does take quite a bit of room. So if you would like to do this on a separate piece of paper, you may. I'm going to talk about each of these below and explain why certain things, certain methods would be best. So for number 1, this has an a value that is not equal to 1. This a value is 5. Completing the square is very difficult to do when you have an a value that is not 1. I also have no greatest common factor here, so these are not all divisible by 5 or all divisible by 13, etc. So factoring might not be my greatest method unless I can factor using 5x squared. What numbers add to or multiply to 5x squared and add to 13x? Nope, that doesn't work either. So the best possible solution for the first one is probably the quadratic formula. So I think for the first one you should use the quadratic formula. If you want to use the quadratic formula on all of these, you're more than welcome to do so. Number 2, I see that if I only have an x squared term, I can probably solve by using square roots. This is a wonderful problem to solve by square roots on. If you're using the quadratic formula, you need to make sure your formula is equal to 0, so make sure you move the 36 to the other side. You would also be able to solve this problem by factoring with the greatest common factor, but I think the best solution here is by square roots because 36 and 169 are both perfect squares. This one down below, I want to see if x squared plus 4x minus 60 would factor to a nice, easy problem. Nice numbers. So we want to see, well, I know my numbers have to be fairly close together in order to get 4. So it's probably not going to work to use 2 and 30, right? So we're going to try to get bigger as we go. 3 and 20 would not be close enough. 4 goes into 60 15 times. Those are closer, but not quite. 5 goes into 60 12 times. Those are closer, but still not 4 apart. 6 and 10. You probably thought of 6 and 10 right away because those are easy numbers, and so hopefully you realize that a -6 plus a +10 would multiply or would add to 4x, but those two numbers would also multiply to -60. So you can factor this one if you would like. Some of you might have already used the quadratic formula and finished it by now. I'm not sure. So I think I would factor this one because I would be able to easily see that 6 and 10 add to 4 and multiply to -60. And the last one I would also say you use by solving by square roots. Realize that that would give you an irrational number. You can't simplify the square root of 15, which you're going to end up getting at some point. So you would just leave it as a simplified radical. So go ahead and solve those 4 problems. When you are finished with that, you need to make sure that you have solved all of your targets on Google Classroom.